Hello there and welcome to A2 Maths from June 2018, paper 2, and here we're looking at the first question of functions questions. So we have the g function, which is 2x plus 5 over x minus 3. Find g of 5. Now this is a composite functions question where we have to put 5 into the g function and then put that answer back into the g function where x is again. So we're going to be replacing x with 5 first of all. So doing the first one, that's going to give us 10 plus 5 over 5 minus 3. Thus that's going to be 15 divided by 2, that is 7.5. And then we put 7.5 back into the g function again because there's two g's, so it's going to give us 2 times 7.5, that's 15, plus 5, that's 20, divided by 7.5 minus 3. Grab your calculator for this one. 12 divided by 4.5, which is equal to 40 over 9 as a top-heavy fraction. Okay, moving on to part B, states the range of g of x. Now we know that x needs to be greater than 5. That's important for calculating the range. It would be really helpful if we had the graph of g of x as well. Now let me show you a little trick for helping you draw graphs like this one here. I'm going to write this fraction here as an equivalent fraction, just written in a different form. I'd quite like there to be an x minus 3 that I can cancel out. So I'll put x minus 3 in the bracket there. That's going to give me my 2x. Then it's going to be minus 6, but I'm going to need to then add on 11 to then create this plus 5 at the end. So it'd be x minus 3 on the bottom. Then splits the two fractions up into two different ones. So it's going to be 2x minus 3 over x minus 3 plus 11 over x minus 3. So this gives us, cancel out this factor from the top and bottom, it gives us 2 plus 11 over x minus 3. So what this now allows us to do is it now allows us to draw the graph of g of x. It's going to be moved up by 2. It's going to be moved right by 3, and it's going to be a positive 1 over x or 11 over x type shaped graph. So the graph of g of x looks something like this, where we have an intercept asymptote at x equals 3 and y equals 2. Okay, so now what will be particularly interesting, we know that x is only going to be greater than 5, so what is the value at 5? So what I can do here is I can plug 5 into any one of my functions that are equivalent to g of x. Let's make it this one here, 2. So at x equals 5. 2 plus 11 over 5 minus 3 is 2. So that's going to be 5.5, 7.5. So that point there is at 7.5 on the y-axis. So now it's going to be x is greater than 5, so it's all of this part of the curve here. And what we're looking for when we calculate the range is the range of the y-coordinates. What are the potential y-coordinates that we can have as our outputs? And in this case, it's going to be anything less than or equal to 7.5, but nothing more than 2. Okay, because that's where the asymptote is. So there we are, that's the answer for part B. Only 1 mark for that, not many marks, a bit disappointing. But let's move on to part 3, part C. Find g inverse stating its domain. Okay, so let's get started. What we do when we're finding an inverse is we set the output letter for the function equal to y, and then what we're going to try and look for is a function that can take us from our output number back to our input number, which is x. So what we're going to do now is we're going to rearrange to make x the subject, make it a function of y. So the way we do this is we multiply up the x minus 3 onto the other side, expand the brackets, then we put all the x's on the same side and put everything else on the other side. So what I'll do is I'll take away 2x on the left and add 3y onto the right. Then to turn 2 x's into a single x, we factorize, and then we divide by what's inside our bracket, And there we are. So our answer to this question is G inverse of x. Now what we do as our final answer is we don't write the letter y, we write the letter x. So it's 3x plus 5 over x minus 2. So that's the inverse function of g. What we've done here is we've rearranged this equation, but it's basically the same as this equation here, just not g of x, we write y instead, and then we just rearrange it to make x the subject. It's really important that you know how to do this step, which turns 2x's effectively into 1x by factorising. And we also have to state the domain. So the domain of the inverse function is going to be the range of the original function. So we've already worked that out. So we've already worked out that the range is equal to this thing here. And just to remind you, if you have your function g of x and g inverse of x, then the domain crosses over and it's now the range of the inverse function, and the domain of the inverse function is now the range of the original function. So they cross over. This is equal to this, and this is equal to this. So the domain for this function is going to be x is in between 2 to 7.5. That's the domain for the inverse function. Okay, so there we are. That's the answer to question 1. 6 marks for that question. Let's now move on to question 2.